Very good morning, good afternoon, good evening to all my friends, participants and candidates who are taking this NPTEL MOOC course, the title of which is Application of Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, the three broad areas which are covered under this course. Number one is averaging technique and forecasting concepts. The second one is regression model. Third one is time series analysis. And we are in the area or domain of the first one, which is basically averaging techniques and forecasting concepts. So, we are starting today is basically the starting of 5th week, which is the 21st lecture, which that technically it means the first lecture of the 5th week. Now, as you remember in the last class, which was the last class of the 4th week, we covered in detail the Holt linear method and considering the concepts of alpha and beta, where the concept of alpha was to be added, where you had a level and a trend, and beta was basically the error, not the error, the concept which was basically being added for the ideas of the trend. So, level and the trend actually means I have explained again, level as which level from which value is starting, and trend basically means which is given by B and level being given by L. So, trend would give you per unit time change how the overall the data set is changing, where did the data set I imply by y is the actual data and f is the forecast. And considering different values of alpha and beta, like example 0.2, 0.2, 0.2, 0.4, 0.2, 0.6, 0.2, 0.8, where the first point number which I am saying is basically related to alpha and the second one is for beta. Then again I changed alpha to 0.4 and took again the same sets of beta and correspondingly all different combinations, and they were illustrated for the average absolute error, average mean or standard deviation, and based on that the third metric was the mean value. Mean value means with the sign, absolute error would be without the sign is plus. And I showed that for lower values of alpha, higher values of beta, you can basically have different combinations which will give you the best fit. And we dealt a long time in that discussion. And we had also done a similar problem earlier, where it was related to the furniture company of IIT Kanpur, where based on the data, I would basically consider the forecast value and the actual value and then proceed one step at a time. That means, consider F1, Y1, I basically forecast for F2. Then considering F2 and Y2, I forecast and find out the value F3 and proceed accordingly. Now, the other question which I also answered was that apart from this metric, mean absolute error, mean squared errors, the standard deviation, you can consider so weighted mean, you can consider the percentage error, you can consider the weighted percentage error, you can consider U statistic. All these things would basically be you are able to calculate and utilize that to find out which is the best model. And also I pointed out in one of the examples that all the models may not give the best result under all the metric. So, depending on the metric you choose, you have to be careful that which metric is choosing in under which circumstances. And if we also remember, I specifically specified few important points about the metric when we were discussing the concept of mean squared error, mean absolute error, weighted absolute error, weighted mean square error, the concept of percentage error, weighted percentage error, U statistics, and I specifically mentioned concept of U statistics when it should be used. We also discussed the naive method. Now, why I am basically discussing is basically a recap for all the different metrics which you used, all different techniques we have used till far. and tilfar it means we have used different concepts of moving average. The odd number moving average, even number moving average. Odd means 3 month or 5 month, even means 4 months, 6 months, 8 months. Then we also consider 2 into 4, we can consider 3 into 3, we can consider 3 into 4, we can consider 5 into 4 into 4. And at the end of the day, basic idea is to find out what will be the forecast the next period. Remember, in all those detailed symbolic representation, the main idea was to basically find out why not. Then we proceeded for exponential smoothing, one parameter not adjusted, that means fixed, the multi-parameter not adjusted, say one parameter adjusted, multi-parameter adjusted. Then we went to the trend analysis and then considered the trend analysis can also be considered where you can have more than one alpha, more than one beta, which I mentioned. Now, we will start the last topic, which is basically the Holt Winter method, as you can see the coverage. Now, under the Holt Winter method, basically there are two different methods. There is not much of a difference between them, but how you find out the concept of seasonality, that will be important. So, one is known as the additive seasonality, another is known as the multiplicative seasonality. I will come to the multiplicative seasonality later on in the later classes. The first discussion would be about additive seasonality. So, here again, apart from the slides, I will be utilizing the Excel sheet, because all the problems I have attempted in trying to basically solve all the problems in the Excel sheet, because Excel sheet would be easily available to all of you. And I also mentioned that if somebody is interested to utilize R or Python or SAS or SPSS or Statistica, he or she is most comfortable with, can utilize those packages to basically build up these models. This is not at all difficult, only once you understand, you can slowly build up the coding and do different type of plots, different type of analysis for these forecasting models. Now, what is the basic idea or concept of Holt Winter method and how it is different from the Holt general linear method? The idea is this. If you remember, in Holt general method or the linear method, the overall concept was about the level, which was given by L, the other was trend, which was given by B. Now, a third component would be coming, where we would basically would have seasonality. So, if I want to draw the graph for both level and trend, I have illustrated that when we are doing the concept of Holt linear method in detail. Now, if I want to basically consider the concept of seasonality, remember the concept of seasonality is based on the fact that any year is basically divided into 4 seasons, which I had mentioned: summer, winter, autumn, spring. So, each year it will basically divide into blocks of 4, and the seasonality concept would mean that the overall change of the value basically follows a pattern based on seasonality. It is not cyclicity. Cyclicity, there is a cycle, and cyclicity need not mean it is based on season. It can be based on financial year, it can be based on 2-year factor, it can be based on 5 years factor. There are different things. So, based on seasonality is the important concept which is being added in the Holt Winter method, and as I mentioned, they would be both additive seasonality and multiplicative seasonality. So, if you want to basically draw the graph very simply, so you have the y axis here, you have the x axis here, where x axis basically denotes the time, in the y axis you basically have the y values, which is the actual value. Now, if I have the general Holt linear method, the graph would have been like this. I will utilize red color. So, this is basically the level which was basically being utilized. I am marking L, but basically level means from where you are starting. And the idea of trend would basically be given by the slope, so called slope of this line, which I am just denoting as theta. Now, what would basically added concept of seasonality mean? I will basically try to illustrate that in the same graph. I will use a different color, consider is violet. Same level, but now the change happens like this. So, obviously, L remains same, I will again utilize. So, I should utilize the color of L for the first graph, which was based on Holt simple linear method, as red. So, in the case of when you have the Holt Winter method, whether a additive or a multiplicative, this is also basically L. Now, if I fit the trend, this is the trend, which I can basically find out from theta. So, this I am using different colored theta to make the difference. Now, where the seasonality factor comes? So, seasonality factor comes from this aspect. If you see, there is a pattern which is based on season, that is why it will basically be the concept of seasonality, which would be considered here. So, here you have level, the trend and the seasonality, and as I mentioned again, seasonality can be considered as additive and multiplicative. The concept of additive and multiplicative means that the factor based on which the change in the values happens on the season need to be added up. That means, they are not increasing to that quantum, but in the multiplicative one it will be changing by much more. The seasonality fact concept will be there, but the change would be much more. And as I mentioned, I will be switching between the PPT slide and the Excel sheet to make things much clear. Now, the Holt Winter methods, this additive seasonality, what is the nomenclature? There is not much a difference, they would be added few more nomenclature for more variables. So, let us not get confused, when we come to the problem we will solve it. Now, the factors are, and I will mark the important concept here with a different color highlighter. So, to make it much more understandable for all the candidates and the participants who are taking this course. So, I will use the green one. Now, the first concept is basically alpha, and this is the concept of alpha which we have seen in the case of the Holt linear method, where the forecast value was basically calculated based on the level and the trend. Here basically alpha is the concept of the weight, so called weightages or the parameters, which is basically coming for the fact of level. So, what you have is basically this: there is an extra term capital S and there is an extra term small s, that is point 1. There is also an extra term of m. Now, let us basically understand them one by one. The concept of capital S is basically the factor based on which the seasonality component is being found, component, the value, while S is basically the seasonal time. So, it is 4 months, 6 months, whatever it is, that is small s is basically seasonality time. And what is M? If you remember, we have already utilized M in great details when we are considering the Holt linear method. M is basically how many time periods ahead you are trying to basically forecast. So, M is 1, that means you are only forecasting one step at a time. If M is 2, you are basically trying to predict or forecast 2 steps at a time. So, M means how many steps forward, S, small s means basically the concept of seasonality in the time frame, and capital S basically is the value based on which the seasonality component is being brought into the picture for the calculation. Now, as I mentioned, L is the level, alpha is the corresponding, I am repeating it, alpha is basically the weightage is being given to the component of L. So, what you have is basically YT, which is actually we know is the actual value based on time period T as of today. Capital S is basically the component of the seasonality, and if you remember, it is T minus S, that means we are standing today and we are trying to basically find out the effect of seasonality, one so called cycle. This cycle I am using is basically not the concept of cyclicity, is basically the cycle of seasonality. So, T minus S, which you see in the denominator of in the suffix of capital S, is basically means how many such time periods I have to go back. So, t today, t minus s is basically how many time periods I have to go back to basically inculcate or bring into the concept the factor of the seasonality, which is given by capital S. And here on the other term which you see is basically 1 minus alpha, and the sum is basically the level, which is L, and other is the trend, which is B. And obviously, they are, as per the concept, the level value is at one time period in the past, which is t minus 1, and the trend is basically one period in the past, which is t minus 1. Now, this component, if you see the one which I am going to highlight using the orange one, this part we have already seen in the linear part, in the sense that there it was given by the factor. If you look at it closely, there were the weights of alpha and 1 minus alpha, which were being given or being there for the factors of L t minus 1 and B t minus 1. But now the total weightages or total idea when you want to find out the level is now split into three components. One is the past level, one is the past trend, and one is basically the component of seasonality, which is coming to the picture. So, as I mentioned, in Holt Winter method, there are three concepts: level, trend, and seasonality. The trend is given by the concept, if you remember, is basically I want to find out and give the weights of beta, again between 0 and 1, as alpha is between 0 and 1, and the weights are given by 1 minus beta is given to the past trend, one period back, and beta other 1 minus beta or beta is basically given to the difference in the level. So, basically for the trend also I want to find out the concept of the level of the factors of level and the factors of trend, which is there. So, if I consider the graph for the trend and the time period is like this. So, what I am trying to do is I am trying to find out the BT. BT would basically be the two levels which I have. I will use the black line, this is for t minus 1, this is t, and I am trying to find out the level at these 2 points. So, this is basically the two levels. So, difference between them would be here multiplied what is the weightages I want to give, and the B t minus 1 is basically the so called trend or so called the tangent at that point. So, the tangent would basically be, if I use the green line, so this is the tangent at this point t minus 1. So, if beta is 0, it means the rate of change of the today's trend B t is exactly equal to B t minus 1. And if the level is increasing or decreasing, so that will basically change the tangent by level of a theta value either to the left, which is anti-clockwise, or to the right clockwise, depending on the component of L t minus L t minus 1 is either positive or negative. If the level decreases, means the trend in this period t will decrease. If level increases, the trend would basically increase. Just that's the factor, and you are basically adding your concept of the weights depending on the past data. Now, if I consider seasonality, there is a third factor of gamma which is coming, this is the weights. So, what we do is that basically we try to find out the seasonality based on the actual value and the level. So, the actual value and the level would give me the difference and what is the weightages. And here in the similar sense, if the cycle, if the seasonality cycle is there, so I will basically give the weights according to gamma and 1 minus gamma. And obviously, remember t is greater than s, because the factor of seasonality is there in the past. I am trying to basically pick up the information from there and try to forecast for the next time period, depending on already we have trend, already we have the idea of level. Well, now we are trying to bring the concept of seasonality. Now, here SI, capital SI is basically given by YI by LS. LS would basically be the level at that seasonality value, and LS would be the sum of all YI, Y1 to YS divided by S. S is the time period, and here the concept comes is that if you add them up, it is basically known as the additive model as stated, and as I have been mentioning, that concept of seasonality is being added. So, the point bullet point black after the fifth point basically considers the seasonality in the additive sense. The level equation for Holt Winter method differs from the level equation of the Holt method, as we need to subtract here. That means, in the additive one you add up and then subtract to basically regain the value, while in the multiplicative one you multiply and then divide to come back to the value. So, these are the only differences to basically de-seasonalize the concept or the weightages of the effect on y t, which is basically the actual value based on which you are going to forecast. So, here what I have explained, y t is basically the actual value, f t plus m is the forecasted value, m time periods ahead, m is 1. So, it will be f t plus 1, L t is the level of series, which is the smoothened average value of the series that does not consider seasonality. That is important. Seasonality and level are totally two different things. Level is from where you are starting, trend is basically the average increase, and seasonality is basically depends on the season. There were three different concepts. So, let me continue reading it. So, level of the series L t, it does not consider seasonality, B t is the trend, capital S suffix t is the seasonal component, small s is the level length of seasonality in time frame, m is the time period, which is how many times ahead you are trying to forecast, corresponding alpha, beta, gamma are the weights corresponding to the level for alpha, then for trend, which is for beta, and for seasonality is gamma. So, alpha, beta, gamma are chosen in such a way that the sum of the weights of the squares is minimized. That is basically the crux of the problem which you are trying to solve. Now, for the additive seasonality, here is the data. So, if you see in the slide, I will immediately go back within few minutes back to the Excel sheet where we will solve. You have the first column, which is the year, the second column is the quarter. So, each year there are basically you are considering the quarters. So, first quarter, second quarter, third quarter, fourth quarter, that basically makes 12 months. So, that is marked in the or because there are 4 quarters like 1, 2, 3, 4 first year, 1, 2, 3, 4 second year, 1, 2, 3, 4 third year. So, hence the period has been marked in column 3 starting from 1 to basically 24. Then in the fourth column you basically have y, which is the actual value, and then fifth, sixth, seventh, eighth are basically again the repetition of year, quarter, period and the actual value. So, now I will basically try to solve the problem. Okay. So, here if you see, just for some information for your case, yes, this I am mentioning, but it will change depending on the problem how you are solving. So, the starting values you can assume. So, need not be there in the Excel sheet, because we keep changing these values depending on what is the optimum value you want to find out. So, alpha is taken as 0.882, beta is assumed as 0.055 and gamma is assumed as 0.00, and S, small s is 4, which is basically 4 time period or 4 months. To initialize the Holt Winter forecasting method, we need initial values of level, which is LT, the trend BT, and the seasonal index is ST. So, those are important based on which how we proceed. To determine the initial estimate of the seasonal indices, we need to use at least one complete season data or S periods to basically find out the best estimate, and we will see that in the Excel sheet. Now, the starting values how they are done, and here even though explaining would not make sense, that when you come to the Excel sheet it would be much more better appreciated. So, you have LS, which is basically for the additive model is the sum. So, y1 to ys is basically the sum which you have. So, LS is basically the concept of the level which you have based on the seasonality time frame, and small s is basically 4, and y1 to ys would basically be based on the past data. You will take y1, y2, y3, y4 divided by 4. If the component of seasonality was 6 months, you would have taken y1, this suffix which I am saying y1, y2, y3, y4, y5, y6 for the case when the seasonality concept is 6, that would depend on which stage you are. I am just giving the concept for the suffix, that so that you do not get confused. So, in the case when you have the 6 time frames, it will basically be the average of 6 terms of y. And this concept of BS, which is basically the trend, would, if you remember, we had discussed. So, this I will draw again and highlight here. So, consider the time frame which you have is given in the x axis, y axis you have the values of y, and if I denote the time frame as, say for example, the first, second, third, fourth, fifth, sixth, and if my data is this one. So, what would be ys plus 1 by y1? So, basically if the seasonality concept is 4, so I will go to the s plus 1 at time and minus y1 divide by s, because that would basically smoothen out the values corresponding to s plus 1 and 1. So, the difference of time frame between y1 to ys plus 1 is s. So, I am trying to take the average of the next season. So, starting value of the next season and the starting value of the previous season. Then I will basically find out the average of ys plus 2 minus y2 and continue doing it for y0 minus ys depending on the values, y2s minus s. So, obviously, S1 would be given by y1 plus ls, S2 will be given y2 by ls, and considering there are small s number of seasonality, capital SS would be given by ys by ls. Now, what I mean here is that if the seasonality, say for example, is of 3 time frames, consider here, and I think I should draw it carefully. So, it will be easy for all of us to understand. So, it is 3 factor. So, I am just drawing it simply. So, if I consider this is the trend, correct. Now, this would basically be the starting value for level, and if I consider the S value is 3 months, 1, 2, 3, consider 1, 2, 3. So, this is the first set of 3 months. So, if I consider these values of y s plus 1 and y n are basically the corresponding values of difference between, say for example, here consider I am, and how many time frames, it will basically be 3. So, 1, 2, 3. So, this one. So, and then if I move to y s plus 2, so it will be corresponding to the fact of this time frame by this time frame. So, you will just move in blocks. So, the problem is not yet finished, we will solve it, but I will end this 21st class, and I said that there will be long discussion in trying to basically analyze the problem. So, first class at least in the 5th week corresponding to Holt Winter Method additive model, I took some extra time in trying to explain the concept time again. Hope it is clear, and we will continue solving the problem in details as we have spent the time in explaining it. So, do not worry, have the patience, and once you have the Excel sheet, everything would be clear to you. Have a nice day and thank you very much.